Okay, the first thing we're going to look at here, number 6, is graphing the natural exponential function f of x equals e to the x. Okay, the same properties still apply here that we talked about with exponential functions. You know, that is that the y-intercept is going to still be 0, 1, because if I plug in a 0 for x, e to the 0 power is still 1. Anything to the 0 power is 1. Okay, what if I plug in a 1 for x? Okay, well, then if it's e to the first power, we know that's approximately 2.72. Okay, so I would plot the point here. We could plug in various other values just like we've done before and do the t-chart, but it's still going to be the same shape that we've had with the other exponential functions. Okay. As far as some application problems, if you look at Roman numeral 3, there are some compound interest formulas that we're going to talk about that are exponential equations that you'll have to use. Compound and interest can be done two different ways. Okay, it can be compounded per year or a certain amount of time, or continuous compounding. There's two different formulas. The first one for n compoundings per year is a equals p times 1 plus r over n, and all of this in parentheses raised to the n times t power. Okay, so all those variables, of course, have different values. A is the account balance. P is your principal amount that you begin with. R is your rate. N is the number of times per year that the interest is compounded. And then T is your time. For continuous compounding, you use the formula A equals P times E raised to the RT power. Okay, again, just be careful here when you're typing these in to your calculator. Only the E is raised to this power, okay, not the P. So again, A is the account balance, P is the principal, the initial amount you begin with. Then we have our natural base E, R is your rate in decimal form, and T is your time. Some of the problems on the homework may give you the formula, but I do want you to make sure that you know these and are familiar with these formulas. Okay, number 7 says find the accumulated value of an investment of $10,000 for 5 years at an interest rate of 5.5% if the money is compounded semi-annually. Okay, semi-annually means twice a year, so that means this is where my n is going to equal 0. Okay, let's look at the information that's given. The initial investment is $10,000, so that's my P value. The T, the time, is 5 years, and then my interest rate, if I would change this to a decimal, would be 0.055. Okay, so I'm going to plug those values into the first formula. We want to find what the account balance would be, so we want to find A. So that would be 10,000 times 1 plus 0.055 over 2 raised to the 2 times 5 power. Okay, on my calculator, you know, I would not type 2 times 5. I would go ahead and know that that means 10. Okay, so again, you'll have to look at your calculator, how it functions. The order may not be exactly the same. But what I would do first is what's in my parentheses. I want to know what is 1 plus, I may open parentheses, 0.055 divided by 2, close the parentheses. So I have 1.025. That's raised to the 10th power. So I hit my exponent key. 10th power equals, and then I would say times 10,000. Okay, so the account balance would be $13,116. Let's see, does it tell us It doesn't tell us to round. I'm going to go ahead and round to the nearest dollar. Just make sure that you go by the directions that are on the homework for this. Okay, part B says compounded quarterly. Okay, quarterly means 4 times a year, so my end value would actually be equal to 4. Everything else is the same, so I would have A equals 10,000 times 1 plus 0.055 over 4 this time, raised to the 4 times 5, so that would be 20. So again, I would do 0.055 divided by 4 plus 1, so that's my value in parentheses, raise it to the 20th power, hit enter, this is what I get here, then times 10,000. And so I get an account balance of $13,141, okay, which we see is a little bit more, okay. And then we're going to compare that to compounding continuously, which is our formula A equals P times E to the RT. So continuous, my principal was 10,000 times E, my rate 0.055, times time, which is 5. So I would go ahead and multiply 0.055 times 5, and that's what I want to raise E to, 0.275. So I would hit second E, and I don't have to hit equals. Then that would be times 10,000. So my account balance would be $13,165. And so we can see that would be the best bet. It may ask you on the homework which one is the better return for your investment.